So I is just equal to I. Who remembers what I squared equals? -1. I to the power of 3 can be separated to I squared times I. And if I to the power of 3 is I squared times I, that means that it is -1 times I, which is what? Nope. What's -1 times I? What's -1 times x? Negative x. So what's -1 times I? Negative I. And then I to the power of 4, that can be broken down to I squared times I squared, which is -1 times -1. And what is -1 times -1? 1. These are the only 4 answers that are acceptable. When you're asked to simplify I, if you're not telling me one of these 4 answers, it is wrong. All right, now let's keep going. I to the power of 5.
Isn't I negative itself? Like, isn't that like...
I is equal to the square root of -1.
Yeah, so how do you make a -1 -1 without turning it into 1? You get what I'm saying?
Nope. Say it one more time. So I is equal to the square root of -1. That's what I is equal to. That's, I mean, you know, we really don't, but it's actually equal to that. So you're asking me for I to the power of 3?
Yeah, I'm asking negative I, because isn't I already negative?
No, I is positive. Yeah, I starts off positive. Now I got you. End of the day, my brain ain't really, you know. All right, so now we're going to keep breaking this down. So I to the power of 5, I'm going to separate that down to I to the 4th times I. Because what did we say I to the 4th was equal to? 1. So what that means is I just have 1 times I, which is just I. I to the power of 6 can be separated to I to the 4th times I to the 2nd, which means I to the 4th is just 1. I to the 2nd is -1. And 1 times -1 is -1. I to the power of 7 is I to the 4th times I to the 3rd. I to the 4th is 1. And what did we say I to the power of 3 was? -I. I to the 8th is I to the 4th times I to the 4th, which is 1 times 1, which is 1. Notice what happened here. See how it repeated? That's what it does. It repeats. So every 4 powers, we do a repeat. We start back. It's like a Ferris wheel. We just keep going around. So when I look here, when you look at the top, I want you to notice how we just repeated the same 4 answers. So I and I to the 5th are the same. I squared and I to the 6th are the same. I to the 3rd and I to the 7th are the same. I to the 4th and I to the 8th are the same. What do you think, without doing a whole lot of this work, what do you think we're going to get for I to the power of 9? We're back to the top. So we got I. What do you think we're going to get for I to the power of 10? -1. What do you think we're going to get for I to the power of 11? -I. And what do you think we're going to get for I to the power of 12? 1. When you are simplifying I, the only thing you need to have memorized is the first column. This is all that matters. If you know that, then you can simplify I to any power. This right here, this is the important component of simplifying I. So now we're going to count by 4s. It's my 4th time doing it. Let's see if y'all can we get up to 100 counting by 4s, and I'll explain why in a minute. I need a nice little choir. I need everybody. So 4, 8. We got to get to 100, so keep going, y'all. 12. Okay, 6th period did a whole lot better. Come on, y'all. Let's count by 4. I need a little louder. 20. 32. 52. 66. 56. 80. Almost there, y'all. All right, this is important. The reason why I did that, and of course I could keep going, but I'm not, is that anytime you get I to any one of these powers, you need to know that the answer will be 1. Okay, because these are all factors of 4. And remember, every time we hit a factor of 4, the answer is 1. We are going to, after we hit that 4th factor, we're going to start back to the top. So, with that in mind, now let's do some higher powers, because these are the kinds of powers that you'll have to do on the test. So take a moment and copy these 4 down, and then we'll talk about it. So we got I to the power of 29, and then we have I to the power of 67, and then we have I to the power of 42, and we have I to the power of 24. So keeping in mind what I just said, every time we hit a factor of 4, we do a reset. Looking at the numbers that you all helped me write on the board, what's the highest factor of 4 that I can reach before I go over 29? So how high can I go before I hit a number bigger than 29? 28. So this is what I want you to do. I want you to separate this to I to the power of 28. And how many I's do I have left over? If I had 29 and I take out 28, I have 1. So this is going to cancel itself out. So essentially, all I have left is I. And we know that I equals I. So that means I to the power of 29 is equal to I. And that's my answer. All right, 67. Looking at my list. How high can I go without going over 67? 68? 68 is more than 67. 64. So how many do I have left?
3.
This cancels out because this equals 1. And then remember I said if you know these, then you know them all. I to the power of 3 is what? Negative I. So that would be my answer. Notice how I can tell that that's an I. So make sure I can see the dot. All right, I to the power of 42. How high can I go without going over 42? 40. How many is left over? All right, what's I squared? -1. And then 24 happens to be on my list. So what does that mean? What does that equal? 1. All right, I'm about to give you 4 for you to try to do on your own. And I'm making these up. Every class period, they've been different. So, and we're going to just give yourself a little mini quiz. See how many you get right out of 4. All right, so let's do I to the power of 63. And then I want you to do I to the power of 97. And then I want I to the power of 76. And then I want I to the power of 50. Do those 4 on your own. All right, when you have your 4 answers, put your pencil down so I know who I'm waiting for. All right, talk to your neighbor. Everybody find a friend. Y'all gotta let Fatima in because she by herself. So put her in the loop with y'all. All 3 of y'all. Y'all triple. Y'all trio. And again, I made these up. I don't know the answer. All right, let's see how we did. What did you all come up with for I to the power of 63? Who got -I? I would agree because we can go up to I to the power of 60. I have 3 left. I to the power of 3 is -I, so that should be your answer. 97, what did you come up with? 1 or I? Who said 1? Who said I? It's I. 9, not 9. My goodness. I to the power of 96 times I. This cancels out. So I have a positive I left. All right, what about 76? Positive 1. That's one of our factors of 4. What about 50? -1. Good job. Okay, who got at least 3 right? Hands up high. Who got at least 3 right? Okay, I did that. I did good. All right, so we're finished with Appendix 7. That homework is due tomorrow. Let's start Appendix 9. Draw a line. Appendix 9 is also one of the easier ones. The first one is the hardest one. It just gets easier. The first one had a lot. Quadratic formula, factoring, completing the square. I mean, it was just too much. Appendix 7, not too bad. Appendix 9, not too bad. So you don't need to copy down the homework assignment because that is on Canvas. I just took a screenshot. The only thing I would do is title your notes. So this is Appendix 9, so I would put that, and that's it. So we're going to talk about interval notation. Interval notation. I'm going to do a quick review of interval notation. That is how you're going to show any of your answers in this class where there's an inequality. Domain and range. All of that is always interval notation. Okay. So you don't need to copy this down because actually I was going to pass it out and have you glue it. I think it's confusing. I don't really like it. So I'm going to do it my way. This is the 3 things that you need to know about interval notation. Number 1, if you have one of these, then you're going to use a bracket, a hard bracket. So if your inequality is equal, you're going to use a hard bracket. This is called a bracket. And make sure I can tell it's a bracket. It should be pointy corners. If it's not equal to, then we just use regular soft parentheses. And then the last thing to keep in mind for interval notation is you always start with the smallest first and you go to the largest. So anytime you're putting your interval, the first number should be smaller than the second number. And that's really all you need to know, okay? Because that table is doing too much. Let's just not do that. We don't have that much left to do. Number 1, because I'm tired. But we are going to practice writing things in interval notation, and then we're going to solve one inequality, and then that's it. So go ahead and copy this down. And I'm not really concerned with the graphing in the homework for homework 3. If it asks you to graph it, I'm not really worried about that. You don't have to graph it. I just really want you to write it in interval notation. So go ahead and copy down these 4, and then we'll go through them together. Okay, so for number 1, this interval starts at 0 and it ends at 4. The 0 is equal to, and so is the 4. So both sides would get a hard bracket, and that's it. That's how you write that in interval notation. For number 2, only because that's an open interval, I'm going to just kind of graph it out. So first of all, who can tell me, is this greater than or less than? Who says less? Who says greater? So the way I remember it, this is how I remember it. If it looks like a L, then it's less than. And if you look at this, this doesn't look like a L, it's backwards. So that's greater than. Now on the 8, we would use an open circle because it's not equal. And because it's greater than, it would go to the right. which means it's going towards infinity. So in interval notation, I would say we're going to start at 8 and end at infinity. That's how I write that in interval notation. The 8 gets a soft parentheses because it's not equal. Infinity always has a soft parentheses. And that would be your answer. Question number 3. We start at -1 and we end at 2. -1, does that get a soft or a hard? A soft, because it's not equal. Okay. So that's what we're going to do. We're going to just stop working with just a few minutes left. Okay. All right. What about the 2? What would that get? Hard. All right. Last one. And then we'll do our inequality. Now that's a less than because it's opening in the same direction as an L. The 3 now has a closed circle and it's coming from the left, which means it's coming from negative infinity. So this interval is starting at negative infinity and it's stopping at 3. Negative infinity, just like positive infinity, gets a soft bracket, and 3 will get a hard bracket. One last question, and we are done. See if you all remember how to solve it. It is 2:11. We're almost out of here. Don't worry about the graphing part. I'm going to take that off. And I only want you to do this one question. So I'm coming. All right. Go ahead, take a moment, see if you remember how to solve an inequality. And then your answer needs to be written in interval notation. So I'm going to give you a couple of minutes to do that. And while I'm doing that, I'm going to pass out a sheet of paper, and I'll explain what that paper is after we finish this question. Together, and then I'll explain what that sheet of paper is that I passed out. What did you do first to solve this inequality? What was your first step? Well, you could subtract the 7 over, or you could distribute, either way. I'm gonna start by distributing, which would give me 2 minus 12a plus 7 is less than and equal to 93. Now I'm going to combine my like terms. That would be these two. And do you see how they're both positive? So that means when I add them, it becomes a 9. So I have negative 12a plus 9 is less than and equal to 93. Subtract the 9. And what do you get when you take 93 minus 9. 84. So negative 12a is less than and equal to 84. All right, last step is to divide by a negative 12. Who remembers what you do when you divide by a negative? Flip it. So I get a, now it becomes greater than and equal to. And what is 84 divided by negative 12? This is my answer, which in Algebra 1 would be fine. But in pre-calc, you need to write it as an interval. So this is starting at negative 7. And it's a bracket because it's equal to. Because it's greater than, is going towards infinity, which gets a soft bracket. This is the only acceptable answer that will give you full credit. You can do all of homework 3 now, just so you know. It doesn't even take a whole sheet of paper. It's not that bad.